friction, let's take a simple case where there is a block of mass m which is resting on a surface. The surface is not frictionless, this is horizontal surface, and from here a force F is applied in the horizontal direction. So that we can draw the forces on the lower surface, that is friction forces, I have diagrammatically just lifted it up. Otherwise, in reality, this block is resting on the surface which has some friction. Let's say we apply a force of 5 Newton. This block doesn't move. This block doesn't move because there is a force of friction in this direction. This block does not move because this friction force is, generally the students they say, most of the students they say, because this friction force is bigger than 5 Newton. Had this force been bigger than 5 Newton, so it means that is, if this is bigger than this, it means the net force would have been in this direction. If the force resultant or force net, it has to be in this direction, it means the block should have accelerated in this direction. But we have never observed, let's say if block is lying somewhere on a horizontal surface, we apply a force this way and it starts moving this in this direction. That doesn't happen. So over here, what we say is, when we apply a force of 5 Newton, this block doesn't move because there is a force of friction this way. And if we see net force is equal to mass into acceleration, when this block doesn't move, that is that there is no change of velocity, there is no rate of change of velocity, that is there is no acceleration. If there is no acceleration, the resultant force, it has to be equal to 0. It means this friction force, it must be equal to this 5 Newton force only. So friction force is not bigger than this, but it is equal to that as long as this block is stationary. When we talk about the force of friction, friction being a force, it is a vector quantity. It has got magnitude also, it has got direction also. So let's first take what is the direction of friction force. We have understood that is between this surface and this surface there are irregularities, they are there. When we try to move it, when we try to push it, these irregularities, they pose some resistance. If we just take these two irregularities, that is instead of taking so many irregularities, if we just focus on just one irregularity, this is the irregularity of this and this is the irregularity of this. They are meshed like this. They are meshed like this. Let's focus on just one irregularities. So as soon as we try to push it, we see that is this finger, it tries to move in this direction, whereas this irregularity, it experiences a force in the backward direction. It means through these irregularities at the surfaces, this applies a force in this direction and this applies a force backward in this direction. To our reaction, there is equal and opposite reaction, and action and reaction, they are always on two different bodies. This is also friction force, this is also friction force. The other simple example could be that is how the car accelerates or deaccelerates. Initially the car is stationary and it starts moving in this direction. Then obviously the wheels, suppose both the wheels they are powered. So then what happens is that this wheel tries to rotate this way. When it tries to rotate this way, this portion which is in contact with the road, so when it tries to move it this way, it pushes the earth in the backward direction, and earth pushes this wheel in the forward direction. Same thing happens for this. This wheel pushes it this way and this pushes it this way. It is because of these two forces this car accelerates in the forward direction. If all the wheels they are not powered, that is they don't get a power from engine, then those wheels which are getting the power, they'll be creating a forward force like this. If we take the example of bicycle, where only the rear wheel is powered, that is when we pedal it, then the rear wheel has a tendency to move it in this direction. As a result, because of interlockings, the friction force is in this direction and this applies a force in this direction, the forward direction. To our reaction, there is equal and opposite reaction, and action and reaction, they are always on two different bodies. When it tries to rotate it this way, when it is pedaled and it applying a force, then it accelerates. If we talk about the front wheel is not powered. So as a result, when through this, it gets pushed. So interlockings, they are like this. So these interlockings, they are not powered. When they try to move it this way, the friction force onto this is in this direction and friction force onto this is in this direction. It is interesting to note that is direction of friction force in both the wheels is different. When someone is pedaling and trying to accelerate, this friction force will always in this direction. When the cyclist is accelerating, then friction force will in this direction. when the cyclist stops pedaling, then this friction force, it changes direction, and this is once again because it's friction forces, because now it is not powered, it is not being pushed by the cyclist in the backward direction. So as a result, that is the friction force, now it will be in this direction. Coming back to our previous example, where we had applied a force of 5 Newton on a block of mass 5 kg, the surface is horizontal, the force which is applied, that is also horizontal, and we have seen that this block, it doesn't move. It doesn't move, so that's why the direction of friction force here and here, that is the direction of friction force. This is also friction force, this is also friction force, and this friction force arises because of interlocking or meshing of the irregularities. Deeper and stronger is this interlocking, more is the friction force. Over here in this case, first we apply 5 Newton, this block, it doesn't move. When it doesn't move, it means acceleration is equal to 0. If the acceleration is equal to 0, it means the resultant force, it has to be equal to 0. When the resultant force is equal to 0, it means this F should be equal to 5 Newton. So this F should be equal to 5 Newton. Now what you do is, you slightly increase this force to, let's say, to 10 Newton. You observe that still it doesn't move, the block doesn't move. If it still doesn't move, it means now the friction force must have adjusted itself to 10 Newton. Because once again the acceleration is equal to 0, on the same logic, when the acceleration is equal to 0, the net force has to be equal to 0. It means this side forces has to be counterbalanced by this side forces. And this side force, there is only one force, there is no force which is acting this way. So the only force which must be arising is only at the interface only. And this force must be equal to 10 Newton because this is not accelerating. So now this force, which was earlier 5 Newton, now it has changed to 10 Newton. We increased to 15 Newton and still doesn't move. So it means once again acceleration is equal to 0, once again the net force is equal to 0. So it means that is this has self-adjusted itself to 15 Newton. So now it has become 15 Newton. But at one value, when we apply this force, it starts moving. It starts accelerating in this direction. Then this force, suppose at 20 Newton it starts moving, it starts accelerating this direction. So it means this force is now greater than this force, friction force. As a result, it starts accelerating the forward direction. So it means friction force is self-adjusting, and it is self-adjusting up to certain limit. This maximum limit to which the friction force can go is called limiting value of friction force or maximum value of friction force. And the value of this, the magnitude of this friction force, that is what we call F maximum, or you can also say limiting value of friction force. Limiting value is mu, coefficient of friction, into normal reaction. This is normal reaction. Normal reaction is obviously reaction, the unit is force only. Action and reaction, they are the forces only, the unit is Newton only. This is a maximum value, obviously it is in Newton only. This is Newton, this is Newton. So mu, that is what you call as coefficient of friction, that is what you call as coefficient of friction. It doesn't have any units, it is purely a number, and it depends on the roughness between the two surfaces. Generally we say that is coefficient of friction is between two materials like wood and glass and plastic. Generally we say it like this. And normal reaction is always perpendicular to the interface. In most of the times, that is at elementary level, when we are dealing with number of cases where the normal reaction is equal to mg, then the students mistakenly, unknowingly, they start taking normal reaction is equal to mg always. Please understand that normal reaction may or may not be equal to mg. It depends from case to case, that is when it is mg and when it is not mg. Now let's say we have a case like where we have a block of 20 kg resting on a surface, horizontal surface. 5 Newton is a horizontal force which is applied onto the block, and coefficient of friction between these two surfaces is 0.1. We are asked, that is what is the value of this friction force at this moment when a 5 Newton force is being applied onto this block like this. So for that, what we do is, first of all we find what is the maximum value or limiting value of friction force. The maximum value of limiting value of friction force is mu into n. Mu has been given, so let's come to the normal reaction. For normal reaction we can draw the force diagram. Along the y-axis we observe that is earth applies a force of 200 Newton. Earth says I am going to pull you down with a force of 200 Newton. Because of this pull, this block pushes this block. Because of this pull, this block pushes this surface in the downward direction with n, that is normal reaction perpendicular to the surface. when this block pushes the surface in the downward direction, then this surface or this body will also push it up in the upward direction. To have reaction, there is equal and opposite reaction. Action, reaction, they are always on two different bodies. So the forces which are associated with this block along y-axis, there are two forces. One is 200 Newton in this direction, and the other force it is experiencing is n in the upward direction. So let's concentrate on the forces which are associated with this body only. So one is 200 Newton, the second is normal reaction. And we observe that is the block is stationary along the y-axis. Along the y-axis, it is not going up and down. So it means the acceleration on the y-axis is equal to 0. If the acceleration along the y-axis is equal to 0, then it means resultant force along y-axis, it has to be equal to 0. Resultant force along y-axis is equal to mass into acceleration along y-axis. When acceleration along y-axis is equal to 0, it means the resultant force along y-axis has to be equal to 0. When the resultant force along y-axis has to be equal to 0, it means the downward force it has to be equal to upward force. It means the normal reaction should be equal to 200 Newton. Please don't cancel n and n. Please do not cancel this n and this n. This is the force, this is the unit of force. That is normal reaction force is equal to 200 Newton. Now we have got the value of normal reaction. So we can now easily find what is a maximum value or limiting value of friction force. So we find F max or F limiting, mu is 0.1 into 200 is equal to, that comes out to 20 Newton. It means the value of friction force, maximum value of friction force. Now this is a point to be noted. That is, this is not the value of friction force, this is the maximum value or limiting value of friction force. That this is the limit to which this can go, this value of friction it can go. This value of friction it can rise to 220 Newton. This value of friction force it can rise to 20 Newton. It can go to 20 Newton. It cannot go beyond that. And before that it is a self-adjusting case. Like we cannot say that is a force of 5 Newton is applied and 20 Newton, because this is 20 Newton, so 20 Newton is this direction. If this is, we say that is friction force right now is 20 Newton is in this direction, so it means 5 Newton is this way, 20 Newton is this way. So as a result 15 Newton should be in this direction. 20 minus 5, 15 Newton, it should be in this direction. So it means, it should mean that is when we push it this way, this block should be start accelerating in this direction. It doesn't happen. Frictional force is a very humble force. It says I'll self-adjust if your value is lower than me. 20 Newton is a maximum value of friction force. The value, the force which is trying to move it this way is lesser than the maximum value of friction force. So friction force says I won't be 20 Newton. I'm humble enough, but I won't let you move. So this is going to be 5 Newton only. So friction force in this case is going to be 5 Newton and 20 Newton is the maximum value of friction force. If we make it as 15 Newton, the still friction force says that is I can go up to 20 Newton. Till 20 Newton I won't let you move this block. So this friction force self-adjusts to 15 Newton. You go to 20 Newton, this also says 20 Newton. The block doesn't move. As soon as you increase it beyond 20 Newton, then this force says that is now I cannot go beyond 20 Newton, but now I will apply a force of 20 Newton. I will try to stop you with all my might, that is I will apply a force of 20 Newton. So it means that is if someone applies a force of 25 Newton, this friction force now it will not be a humble force. This will try to stop the block with all its might, that is the limiting value of friction force will be used. So this force will be 20 Newton. As a result, the net force now 25 minus 20. This is going to be the net force is equal to mass 20 into acceleration. So 25 minus 20 is 5 by 20 meter per second square. That is the value of acceleration. One of the curious questions could be, what if we apply a force of 20 Newton? Whether the block is stationary or it will start moving. When we say that is we apply a force of 20 Newton and which matches with the limiting value of friction force we have just done, that is limiting value, LTG value, limiting value is mu into n 0.1 into n is 200, so this is 20 Newton. When this force which you are applying is equal to the limiting value of friction force, then what happens? In that case, we say that is the block is just stationary or it is just moving, it is one and the same thing. That is the block is just stationary or just moving is one and the same thing. Why? When we say that is the value of this is 20 Newton, suppose it has reached 20 Newton, and we say 20 Newton. Obviously, all the force, even if we say 20 Newton, there has to be some machine, there has to be some instrument to measure that force. And in all the readings, all the measurements, in all the instruments, there is always some error. They cannot be 100% accuracy. So when we say we are applying a force of 20 Newton, this force could be, that is 19.9999 and so many nines and 10 lakh nines, and then 1 million nines over here and then 9, which is obviously, we see that is, it is less than 20. Whatsoever smaller it may be, it is less than 20 Newton, but certainly it is almost equal to 20 Newton. This is almost equal to 20 Newton. So we should say that the value is this much, then it is less than 20 Newton, so the block should be stationary. Also, if we have the force that is 20.000000001, 2 million 0 and then 1, then this force is obviously greater than 20 Newton, so it should accelerate. But this 20.0001, it is almost equal to 20 Newton. This is also equal to 20 Newton, this is also equal to 20 Newton, this is almost equal to 20 Newton, this is almost equal to 20 Newton. Over here it is stationary, over here it starts moving, this is accelerating. So when we say that is 20 Newton force, that is the force which is being applied, is equal to the limiting value of friction force, then we say that block is just stationary or it has just started moving, is one and the same thing. So if we say this is the force, limiting value of friction force is 20 Newton. If someone asks what is the maximum value of the force that one can apply so that it doesn't move, the answer is 20 Newton. And what is the minimum value of force that should be applied so that it just starts moving, the answer is 20 Newton. Let's take the same example where we have a block of 20 kg resting on a surface, horizontal surface, and the coefficient of friction between these two bodies is 0.1. And over here, in addition to all the forces, weight, etc., there is a one more force, that is someone is pushing it down with the force of, let's say, 100 Newton is being pushed down. Now the question is, what is the minimum value of force which needs to be applied in this direction so that this block starts moving in this direction? This is a common experience when we have a stack of books one over the other and we try to pull out a book which is lower in the stack, then certainly it becomes very difficult as compared to when there are no books on top of it. So it is something like, the case is something like this only. So here what has changed is, that is 200 Newton, this remains as earlier, that is weight of the block mg. This applies a force n in this direction and this is n in this direction. Let's focus on the forces which are associated with this 20 kg block. So on to the 20 kg block. Now earlier this 100 Newton was not there, now someone is pushing with the 100 Newton force. But still, as a result, this is not going to happen that this gets embedded into the surface. It will still be there on the surface itself. That is, there is no acceleration on the y-axis. It means the forces along the y-axis, that is resultant force along y-axis, is equal to 0. When the resultant force along y-axis is equal to 0, it means that is upward forces, they have to equal downward forces. So the downward forces, they are 200 plus, in addition to that 100 Newton, that is in the downward direction, upward direction is n. So n comes out to be 300 Newton, which was earlier just 200 Newton. And we know that is the limiting value of friction force, F limiting, is mu into n. So now it has come out to be 0.1 into normal reaction, now it has changed to 300 Newton. So this comes out to be 30 Newton. So F limiting value, the limiting value of friction force is 30 Newton now instead of 20 Newton. So if we wish to move this block over this surface, then this force should overcome this friction force, be it this direction, be it this direction. Now when the friction force, it has become equal to 30 Newton, and if we wish to move it in this direction, then minimum value of this friction force should be 30 Newton only when the motion will just commence. And when someone pulls this body in the upward direction with a force of 100 Newton, then certainly he will not be able to lift it because the weight of the body is 200 Newton. So it won't get lifted. But over here, this surface will now feel lighter because some weight is being pulled by this person in the upward direction. So now the value of normal reaction, if you are bothered about normal reaction, is once again the body is not moving on the y-axis. So it means upward forces 100 plus n in the upward direction. Let's remove this. We are bothered about this block only. So 100 plus n is equal to 200. So normal reaction, it comes out to be 100 Newton only. 200 minus 100, 100 Newton only. So if this comes out to be 100 Newton, so now limiting value of friction force is mu into n, that is 0.1 into 100, that is 10 Newton only. So it means now if someone tries to move this block in this direction, then he or she doesn't need a value of 20 Newton. At the value of just 10 Newton only, the block can be moved, because the limiting value of friction force now is 10 Newton.